Okay, our second area of dealing with composite figures is what we call shaded regions. So to find the area of a shaded region, it could be composites of the two different areas like we showed you in the first page. On this one though, we have some shaded areas that we need to find the actual area of. So in this case, we're going to take and find the area of the entire figure. Okay, so whatever shape is on the outside edge, that's what we're going to find first. Okay, then we're going to subtract the area that is not shaded. Okay, and whatever's left over then is the shaded portion. Again, you have to identify the shapes that you have. So in this one, I've got a square and a circle. So the entire outside is going to be the square, which would be 20 times 20. So that's how much we're dealing with the whole piece. And then the piece I don't want is this circle. So I'm going to find the area of that circle. That's pi r squared. So remember, r is the radius. It goes from the center straight out. It's telling me up here that all the way across is 20. So that would make this radius 10. So when I come over here and I do pi 10 squared, I get 314.16. So this is the area of the whole thing. This is the area of the circle that I don't want. So I'm actually going to take those and subtract them. To get 85.84 square feet. So that would be the area if I would take these shaded portions here. Obviously, we don't have any formula for, straight lines here and a curve here. There's no specific formula for that. So this is just one way that we could find the total of all those shadeds. Okay, we're going to follow the same procedure here. We've got the whole shape, which is a rectangle. So I'm going to go base length times width. Length times width. So 14 times 25 is 350. So that's the area of the whole thing. I just want the shaded part, so I got to subtract the area of this triangle. So area of a triangle is base times height divided by 2. So if you look here, and sometimes it's helpful to go this way. Maybe that's what you're used to. So this would be like the height, and then this side that it's perpendicular to is the base. So on a rectangle, the big thing, this is 25. Same on the opposite sides there. So this triangle, base is 25, height is 11. So 25 times 11 divided by 2. It's going to give me 137.5. So the 350 is the whole thing, minus the white piece that we don't want. Okay, and the difference between those two, 212.5 centimeters squared, will be the area of just this shaded portion over here. On this one, and this would be kind of a common one, I would think, for several different professions, but we've got to find the area of just this shaded circle. So just as it said up before, up above, we find the area of the entire outside shape. So that's a circle. And all I need for a circle is the radius. So I need to know how far is it from here. I'm going to go up and down to here, right? To the outside circle. So if all the way up and down is 21 meters, that would mean then the radius is going to be 10.5, or half of that. So the entire one is going to be 10.5 squared times pi, which is 346.36. Now, this is the little trickier one. I've got to find the area of this circle that is white to get rid of that so I can find just whatever's left over to be the shaded. So if we think about all the way across, all the way from the center to the outside edge, that is 10.5. This piece, maybe like a grass path or a sidewalk, is 3.5. So that leaves from here to here, that leaves 7, okay? Because from here out, way to the edge, has to be 10.5, the radius of the big circle. So if I go this far, how much is left after I take away this 3.5? That would be 7. So the radius of the circle that we don't want is a radius of 7. So that's going to be pi 7 squared. which is 153.93. So the area of the large circle minus the area of the non-shaded circle is going to give me 192.43 square meters. Okay, so if you have any questions, let me know.